Good morning, everyone. Welcome and thank you for joining us this morning for Teledyne ISCO's April Pumps webinar. Today's webinar is discussing classic syringe pump applications. This webinar is being recorded and will be available to all registrants and attendees later on this week. This morning's webinar is being led by Nick Daddabbo, Teledyne ISCO's Pumps Product Line Manager. If you have any questions or comments during the webinar, please utilize the chat function within Zoom, and all questions will be answered at the end. At this time, I will turn it over to Nick.
Good morning, good afternoon, good evening, everybody. Thank you for taking the time to spend with us and learn a little bit about some syringe pump applications and learn a little bit about Teledyne ISCO in general. So we'll start the day off here really quick since I know we're all very busy. Just a quick introduction. As I said, I'm the product line manager for our pumps division. Been in the business line, product line manager for over 18 years with a few different organizations. Just about 12, 13 years in the pump business line management. So been in multiple different markets. The biggest ones are oil and gas, pharmaceuticals, chemical, and food and beverage. So with that, I'm going to be speaking a little bit about our pumping technology and some of the basic applications that we participate in with syringe pumps. So just to start out, we're going to kind of cover Teledyne ISCO has three different types of pumping technology that we offer. And we'll focus today in on syringe pump technology and the applications, but I want to do overview of the other two types of technologies. First and foremost, obviously syringe pumps, a lot of advantages there, long-lasting design. It's a pulseless design. Very precise flows and allows you to get the higher pressures. These are all very important in many applications, but very strongly important in the reactant feed or reaction chemistry applications. Some disadvantages. Some people may see there's a high cost of acquisition, and the pump maybe has a large footprint and maybe a little bit heavy. But when you look at it from the standpoint of where you're going to use this pump, it's going to be sitting on a counter, sitting on a cart, something like that. So as far as the weight and everything goes, it's not a big deal. It is a very long-lasting design and pump. We have had many applications where the pumps were installed 20 years ago and are still running in that same application, the same pumps. So that's very good to know. The second type of pumping technology ISCO offers is reciprocating pumps. And just think of it like as a train engine. The piston pulls back. You can kind of see the GIF there. It pulls back, draws the fluid in, and then pushes it back out. Pretty easy, just like a train engine. Advantages there: low flow, high pressure, and it's a very common design. So it's proven. Many different types of pumps are out there with this design. I will tell you though, some concerns you have to look at or worry about when you're thinking about this technology is the struggles with viscous fluids, because the check valves sometimes get caught up or clogged up. And it's not a pulseless flow. You can add a pulse dampener to lessen the pulsation, but you will not be able to completely eliminate it or get it down to levels of where the D series is. And the last technology is something we just recently released, is a peristaltic pump technology. There's no wetted parts. All the fluid path is a hose, and it's easy, low contamination, and easily changed. You can just throw away the hose and put a new one on and put it onto a different application. So it's very flexible type pump for as far as functionality goes. Easy maintenance, low downtime, a very workhorse type pump. Hose life does vary depending on the cycles you use, the fluids and the materials you use, and it's definitely not pulseless. So you've got three different types that ISCO offers, and we kind of cover the gamut for the types of applications you would possibly need. So let's take this and let's go right into our syringe pump applications. First and foremost, when you look at the D series, which is our syringe pump technology, these are the key markets we participate in and some of the key applications. Core analysis on the core flooding and oil and gas. Chemical market, reactant feed for batch and or flow chemistry. And then we do dabble into the plastics market as far as polymer creation, foam injection, etc. We'll get into a little bit more about these just a little bit as we go along here. So in the oil and gas market, here is a layout of a typical core flooding application. You can see that the D series in the upper part is the overburden pump, and it also can be used for the test fluid pump. So this is just a general design. When you're looking at core analysis and core flooding, sometimes you have to, when you're thinking about syringe pump technology, you need to understand that you have to have a steady state flow, but make sure you record the pressure drops all the way across the core. You're looking at the effects of salt and brine solutions on cylinder life and seal life, and then temperature requirements and pump specifications. You have to make sure you get those right. You can shorten the life of a syringe pump if you don't have some of the specifications set up right. We tend to be a market leader in this space, and basically the key attributes people look for is the precision and accuracy of our pumps. That goes back to the lack of pulsation in our D series. One feature that is helpful in this market space is the wash gland. It allows for flushing the cylinder of any residue that might be left over from material, and it helps improve and lengthen the seal and cylinder life. These are things that this is an option on our 500 100D, but standard on our 1000D. But this is something that's a nice feature and allows you to get more out of your pump in a longer life and a longer life for your seal. So this definitely, when you're looking at syringe pumps in the oil and gas space, this is a feature you would want to definitely consider to try having put onto your pump. Another key attribute of the syringe pump series that is important for oil and gas is, the Hastelloy packages. The corrosion resistance can be very difficult, and that would be available in a few different options here for us, as far as under the 1000D, in our 100DX, 260D, 500D, and you can also, if you need to, you can order all Hastelloy version of the air valve packages. It's a special order number, special part number, but it can be done. So Hastelloy is something that is important to think about when you're looking at oil and gas applications in general, because some of the things that you're doing with the fluids, or some of the fluids that you're using or pumping, are pretty aggressive. So that's, we can handle that. The D series and any of our syringe pumps can handle that. So you want to make sure you consider that. The next thing that comes into play in the oil and gas applications is the high temperature, a high temperature fluid. Sometimes you're getting, you need to have heat a specific fluid to get it to a specific viscosity, or it needs to stay in the state that it's in, so it has to stay at a certain temperature. There's a different ways to do that. We do have a high temp option that changes the pressure transducer, and gives you a special cap assembly, and allows and compensates for that high temperature need and requirement. Kind of as we go along here, and we put this in here, we have a ton of information on our website as far as application notes and technical bulletins, and these are some key ones that are dedicated or related to the core flooding application or in the oil and gas market. So I would highly suggest that you take a look at these and learn a little bit more how in-depth applications are set up for in oil and gas for using our syringe pumps. Let's look at the chemical market now. And when we're talking about chemicals, it's kind of a broad term. So we've tried to narrow it down a little bit. The type of folks that we deal with here in this space. We get specialty and fine chemicals. You can see the examples of organizations there: agrochemicals, pharmaceuticals, and biofuels, reactant feed. So chemical market is a very broad definition, and this is kind of where we focus into. In the chemical market, there are two types of processes that are used to create new chemicals or new materials or new products. There's batch and there's flow. And batch has been commonly used across the board in many organizations, but there is a trend today that flow chemistry or flow reaction chemistry is increasing. The interest in that is increasing. It's safer, allows you to monitor the quality throughout the process. It's better for the environment. It's just an overall better application, a better methodology from a high level for chemical processing. Not saying anything bad with batch, but the positives for flow chemistry are becoming more apparent with every passing day. And when you look at what flow chemistry really means, I mean, this is really very, very basic, but you're pumping multiple reagents into a controlled reactor and out comes something else. Very, very simple. I know there's very, very much more difficult setups and applications, but this one here is very, very simple. You know, when you're using the syringe pumps in flow chemistry, you need to understand that you have to have achievable and very accurate reproducible flow. You have to make sure it's, in many cases, pulseless, or the pulsation is minimal due to potential for changing the structure of the material that you're pumping. And you need to know you can set the time, set the flow rate specifically the way you want it. And it is very, very common to see that flow chemistry reactions or flow chemistry setups are actually using all three of the types of products we offer. So it all depends on, there's a lot of things up front that you have to consider. You know, what material are you pumping? Do you need to have Hastelloy or corrosion resistance? You know, that's definitely not something you need to consider, much like in oil and gas. Do you need to have, you know, a temperature control? Does the fluid need to stay heated? Do you need to add a mixer to stay in suspension to keep the material in its state that it's in so you can pump it? Or do you just need to move material? That can be done too. Or is your material viscous? That we have pumps that can do all that. You know, some of the advantages in the flow chemistry space is, you know, small reaction volumes, no head space, better temperature control, and easily scalable to production. We have 3 different options that allow you to scale up from whatever you're starting out with in your lab or in your pilot application. As with oil and gas, we have a couple posters that were actually shown at recent ACS shows that are available on our website that you can take a look at and see how the application was set up with using the pumps that we offer. Here's a bit of a diagram, just a basic batch chemical reaction. You can see that, you know, you're injecting you got different flow streams coming into one reactor, and then you're making a batch of something that gets created there. Some of the things that you know, when you look at our accuracy and our low flow rates, you know, the temperature must be stable too. I mean, that has to be important. So to do that, if you add either your own external insulation like heat tape or something like that, or you can add a temperature control jacket that we offer. And it's also important to keep in mind that, you know, pressure fluctuation can really affect the flow rate and can affect your experiment. So you need to make sure that any restriction that you set up is very standard and stable, and always continue to keep an eye on it. Maybe have a flow meter checking the flow rates to make sure it's staying, or monitoring it, so you can set an alarm so it lets you know that there's a flow rate issue. But you want to make sure that stays stable. Sometimes when you have viscous fluids, you know, there are certain things that become difficult with regular standard syringe pumps, where we have that taken care of. We have a HV series that is like a high viscosity series, has a larger opening, more of a straighter on path into the syringe pump, which is kind of helps eliminate some of the issues you might find in some of these trouble spots that are showing here. You know, sharp bends, and if you look at the bottom corner of where the valves are, you know, the viscous fluid have a hard time getting around those bends. Check valves, if you're using a pump with check valves in them, that's could gum up with viscous fluids. So, you know, thinking about that, some of the things that we do to help with that when we're looking at our syringe pumps, we offer a mixer option to allow you to keep the fluid into a more, pardon the pun, fluid state. It allows it to flow through easier. You know, reduce the restrictions. You can change the tubing, you have larger ports, larger tubing. Reduce the sharp angles. We just talked about that. Those are things we recommend. You know, maybe changing the viscosity of the fluid if that's possible, without affecting your experiment. If it's too viscous, can you raise the temperature? We do have a high temperature version. or increase reservoir pressure by adding a pressure pot or just using gravity. These are different methods to handle viscous fluids that you would find when you're using doing some flow chemistry applications. And actually, flow chemistry is used across the board. That terminology is used across the board in oil and gas and chemicals and pharmaceuticals. So that's something to keep in mind when you're looking at viscous fluids. And if you just can't change any of that, maybe it's not a syringe pump you should use. We do have another option there for you. When we look at in mixers, we talked about mixers, and this is just a little more specific on that option. You know, we have it's definitely very good for non-homogeneous solutions and their suspensions. You can see what it would look like if it's put on the top of the pump. That's actually an electric version we have. Well, we do offer an air version, but it goes right in through the pump cap, so it's easy to set up and it can withstand the pressure, and it's a proven design. Again, as with the full chemistry and oil and gas previously, we have a lot of information on the web as far as app notes and technical bulletins that are dedicated to reactant feed. Lots of information here, and we're adding more all the time, so please keep an eye out for it. But these are things you might want to download and just have on your laptop or read, or have it in a booklet for yourself to understand some of the things we have done already, some technical issues you might run into. Third market we kind of play in is the plastics market. Now, plastics, again, is a very, very broad market, okay? But some applications we participate in, you know, adding color to the extrusion process, especially twin screw extrusion, CO2 usage for foam processing for foam injection, and then polymer pulling, creating hollowed out polymer tubes. There's a lot of applications for these across the board. Here's a setup for you for polymer creation and how we do it, and you can see right above the bore fluid it mentions a syringe pump. This is actually pulled off of the web as just part of general information, but it shows you how a syringe pump can be used in this application. The universities are using these syringe pumps all the time for applications like this. It's a truly pulseless flow, so that's very, very important to the application. Plus, we can the D-series syringe pump can pump liquefied gases. That's important. That comes in very strong handy for this. And very precise flow rates. So when you really want to only dose so much of a certain material or so much of a certain color, so you get a uniform look, that is perfect. That D-series is perfect for that. And these are places where you would see polymers, you know, jackets, clothing, stuff like that. Foam extrusion, another application. This is actually a place just at the University of Toronto, and they're using our D-series, so you can see the design of it right there, in their extrusion foaming methodology. You know, it's very important that we have precise flow rates there, and we can pump CO2. That's why they love it. You know, there's other applications they're doing there at the University of Toronto. They're injecting nanoparticles into specific materials, making a material a little stronger and more viable than it might previously have been. And then there's certain things where foam is used, right? So we're looking at certain things here that you can use foam injection, you know, panels on planes, soundproofing panels. You got, you know, sneakers or soles, and, you know, panels in cars, just sound deadening panels in cars. Another application is, you know, at the University of Toronto, you know, when they're creating aerogels, they're using the D-series to pump the polymer through a needle. Very, very precise, steady flow, which is very important to the creation of these fibers. And, you know, they're used all across the board. You look at some applications here, they're used in just flexible materials. The creation of those those are like boat impellers or something like that, or the design of cabs to tractors. You know, you're reinforcing the material, adding like carbon fibers or something of that sort into the material to make it stronger. And the application is being used right now for that, or excuse me, the pumps are being used now for that. Another application for us in the plastic market is injection molding and extrusion. You know, you're dosing of a color in there, or UV material. So if you're creating something, you want to extrude a cup or a glass or something like that, and you want it to be a specific color, or you want it to have UV protection so the color doesn't fade You can use our pumps to slowly dose that agent into the process as the product is being extruded. And here's some examples of kind of where that's, you would see that kind of stuff. We talked about polymer creation earlier, but this is another, kind of another slide that discusses it a little bit. But as with all the previous applications we talked about, we do have application notes and technical bulletins on our website that is dedicated to these types of applications in the plastics market. Now, keep in mind, I've just touched on a few of these things very briefly. But to give you an appetite and whet your knowledge for the types of ways we're used in different markets, as far as a D-series syringe pump or any syringe pump, but primarily we're going to be talking about D-series syringe pump here. You would be able to take these and kind of research these and look for more of these applications, or design your own very easily based off of what you might see either from these application notes or from our technical bulletins, or just doing a little research online. That being said, we have plenty of additional resources available. Like I stated before, we have a lot of technical bulletins and application notes on there. Google Scholar is a great resource for academic research conducted using pumps. We do this all the time. Type in the word syringe pump to see how what's new, what people have coming up, or might have been writing papers about using syringe pumps, or even the Teledyne ISCO pump. So it's very important. You can narrow. There's so much out there. You have to narrow down the scope. And then honestly, if you need help with your application, or you have some questions about how you would use the syringe pump in your application, we have hundreds of years of engineering experience here. We have many people who have been with the company for 30+ years. Lots of people in-house to be able to answer your questions. Just feel free to give us a call. Today, I just wanted to touch real briefly on multiple types of applications within the specific markets. There are lots of them. We could have had this webinar be about 4 or 5 hours, but I chose just to give us a little bit of an appetite to think about it. So, with that being said, I'd like to put out there any questions or any things that might be brought up. Do we have anything? No. Okay. Give us a second for something else to come in. Okay, here's one, Tori. Question is, what about hazardous areas? How do you have pumps that are designed for hazardous areas? You talked about hazardous materials. What about hazardous areas? And we do have a line of HLF series syringe pumps that are hazardous location pumps. They're not going to be class 1 div 1, but they are used in somewhat hazardous areas. So you can use them for oil and gas facilities, chemical facilities. We have seen people do installations where they actually have the cylinder, they have the pump laying on its back, and the cylinder through a wall into a class 1 div 1 area, and the drive and the controller in the non-restricted area. That can be done too. The pump does work well laying on its back, upside down, straight up, doesn't matter. It all functions the same. Anything else? Give it a second here.
And while we wait for questions to come in, I do want to let you guys know that our May webinar will be focused on Teledyne ISCO's new pump, the Peri-Axis. So we'll be introducing that peristaltic pump to everyone. That webinar takes place on May 15th, so be on the lookout for more information coming out on that webinar shortly.
Looks like we got one more here, Tori. The question is, let me read it here. As far as the D-series, can you do continuous flow, and do you have some way to control multiple pumps? Yes, so obviously we can do continuous flow. We can do valving. We have valve systems that are adapted to the pumps that we offer. I talked about that option as far as if you need an all Hestole valve system. We do have the capability to control up to 4 pumps with our controllers. So that gives you a nice option. You can do 2 and 2, or 1 and 1, and then 1 and 1. But if you have the ability to handle up to 4 pumps. And hey, you know, I don't want to be greedy, but if you wanted to do 8 pumps, we'll sell you a second controller too, so you can do all 8. But it is something that is possible and capable to be done.
Okay, we have a few different questions that have come in.
Okay.
Can you pump methane or other light gases under pressure, or should this be done with another approach?
This is Dale Clay, Associate Product Manager. Gases like methane are flammable, so Nick just mentioned the use of, or we have available HL pumps, hazard location pumps. That would be the best pump to pump methane. So it is possible, and I believe that is one of the certified fluids. So that would be a great pump for that application.
Another question that's come in is, can you pump solids?
Well, so we can pump up to very like a consistency of like tar from a viscosity standpoint, but solids themselves, I mean, some particulates are okay, but you are potentially risking the life of the seal if they're bigger particulates.
Another question that's come in. Can you tell us about interfacing to a PLC or related control system so the system can be automated, or must there be a driver available?
This is Dale Clay again. As far as connecting to a PLC, we have a number of options. We have Ethernet, USB, we have RS-232, RS-485, we have 0 to 10 volt and 4 to 20 milliamp. So depending on what your one of those, what you want to use as part of the PLC, we can provide that. Most of the inputs are standard. For example, 0 to 10 volt, the USB I mentioned, and all that RS-232 are all standard. For outputs, then to communicate back to the PLC, then we have to add an optional board for that. As far as the optional boards, we have 12-channel boards. That is, you can hook up to 4 pumps, so we can control 4 pumps on one controller. You get output from all 4 of those pumps for functions of flow rate, pressure, and volume remaining. All feed that information back to a PLC.
We also have LabVIEW drivers available, so if you need to use that for some hooks into your system, that's another method in conjunction with the communication protocols.
Okay, another question that's come in. Are the switching valves rated for the same pressure as the pumps?
The air valves and the electric valves are all rated for 10,000 PSI. The only valves that are not rated for the high pressure is the ball valves. Ball valves typically only go to 6,000 PSI. Therefore, ball valves are typically only used with the 1000D, which is rated at 2,000, or the 500D, which is rated at 3,750. So the answer is yes, the valves are rated for the same as the pump.
Okay. Next question. You mentioned pumping liquids with nanoparticles. What concentration of solids and fluid velocity are recommended to maintain suspension? It would obviously depend on fluid viscosity and particle properties, correct?
As far as pumping particles, the key thing is to keep it in suspension. Most commonly, they'll be pumping a fluid similar to mineral oil, and that tends to keep things in suspension. I think Nick mentioned we can turn pumps on their side or upside down, and particulates don't stay in suspension. As far as concentration goes, there is an apps note or technical bulletin about pumping particulates up to about a 30 to 40% concentration. It really, that increases the viscosity basically, then the issue becomes plugging. So when we start getting to high concentrations of particulates, then we need to upgrade to, say, a 3H tubing. That's when the ball valves are a good choice for that application, and so on. So usually we can adapt your application, and 30 to 40% probably is about the max concentration we can pump.
Great.
Good. I think that looks good. I mean, these are all great questions. We appreciate for your interaction and asking all the questions. We hope you got something out of today and took a little bit away in how we handle different types of applications in different markets. If there's no other questions, I look forward to speaking to you again on the 15th of May. But feel free to reach out to us if you have any questions in between. We have a bunch of people here that can help you out. And if not, we can guide you to where the answer would be found.
Yes, thank you everyone for joining us today, and thank you to Nick and Dale for presenting on this topic. Just a reminder, this is being recorded and will be shared with all attendees and registrants after the webinar, so later on this week. And also just another reminder, May 15th is our next pumps webinar. Be on the lookout for more information coming out for that. Thanks so much everyone, and have a great day.